not all planets orbit stars. Some are completely lost in space. For centuries, humans believed planets could only exist around stars. Stars were the anchors of solar systems, the gravitational hearts that gave planets warmth, light, and purpose. Without a star, a planet was thought to be impossible, just a dead rock drifting endlessly through darkness. But the universe had other plans. In recent years, astronomers have confirmed something extraordinary. Entire planets wandering alone through interstellar space, unattached to any sun, traveling silently through the void. These are known as rogue planets. Their existence is changing everything we thought we knew about planetary systems. A rogue planet is exactly what it sounds like, a planet that does not orbit a star. Instead of circling a sun like Earth or Jupiter, it drifts freely through the galaxy. It's pulled only by the faint gravitational tides of distant stars and galactic structures. Some of these planets are small rocky worlds like Earth or Mars. Others are massive gas giants, larger than Jupiter itself. And astonishingly, many of them may have once been part of solar systems very much like our own. So how does a planet become lost? Planetary systems are violent places, especially in their early years. When stars are young, they are often surrounded by swirling disks of gas and dust where planets are born. Multiple planets can form at the same time, and as they grow, they begin to interact gravitationally. Massive planets can tug on smaller ones, altering their orbits. Sometimes these gravitational battles end peacefully, but other times they end catastrophically. A planet can be thrown into a wildly elongated orbit, or flung completely out of its solar system at incredible speed. Imagine a newborn solar system with several giant planets jostling for position. One close gravitational encounter is enough. A planet can be slingshotted away, escaping its star's grip forever. Once that happens, there is no turning back. The planet becomes a cosmic exile, condemned to wander the galaxy alone. Astronomers believe this process is not rare, may be incredibly common, in fact. Some studies suggest there may be as many rogue planets in the Milky Way as there are stars. That means hundreds of billions of starless worlds drifting through interstellar darkness. If true, rogue planets could be one of the most common types of planets in the universe. Even though they are almost impossible to see, detecting these lost worlds is extremely difficult. Planets don't produce light of their own. We usually find planets by observing how they affect their host stars by dimming starlight as they pass in front, or by causing stars to wobble slightly. But rogue planets have no stars. They are invisible against the blackness of space. So how did scientists find them? The answer lies in gravity. Astronomers use a technique called gravitational microlensing. When a massive object passes in front of a distant star, its gravity bends and magnifies the star's light, acting like a cosmic lens. Even a lone planet can briefly amplify the light of a background star. By carefully monitoring millions of stars, astronomers can spot these tiny, fleeting brightening events and from them infer the presence of an invisible planet passing between us and the star. Using this method, scientists have detected multiple rogue planets, including some surprisingly massive ones. One of the most shocking discoveries was that many rogue planets appear to be Jupiter-sized or larger. These are not tiny leftovers. These are full-fledged planets, massive enough to have moons, atmospheres, and complex internal structures. And that raises a haunting question. What are these planets like now? Without a star, the surface of a rogue planet would be unimaginably cold. Temperatures could plunge to hundreds of degrees below zero. Any atmosphere exposed to space might freeze solid and fall like snow onto the surface. Oceans, if they once existed, would be locked beneath kilometers of ice. Sunlight would be replaced by eternal night. But darkness does not always mean lifelessness. Some rogue planets may still be warm inside. Large planets retain heat from their formation for billions of years. Radioactive elements deep within their cores can also generate heat. In some cases, this internal warmth might be enough to keep subsurface oceans liquid, hidden beneath thick icy shells. These underground oceans would be completely isolated from space, protected from radiation and extreme cold. In other words, Some rogue planets could harbor environments where life might survive far from any star. This idea has forced scientists to rethink what it means for a planet to be habitable. For decades, the search for life focused on the habitable zone around stars, where liquid water could exist on a planet's surface. Rogue planets exist far outside that zone, yet they may still possess liquid water, chemistry, and energy, three key ingredients for life. If life can exist in these dark, isolated worlds, then life in the universe may be far more common than we ever imagined. But rogue planets are not just scientific curiosities. They are reminders of how unstable planetary systems can be, and how fragile our own cosmic situation really is. Earth's orbit seems safe and predictable, but it exists in a system shaped by billions of years of gravitational interactions. If Jupiter had migrated differently in the early solar system, Earth might never have formed, or it could have been ejected into space long ago. Our planet's survival may be the result of cosmic luck. Some rogue planets may even pass through star systems as they drift. Briefly becoming visitors from the dark, they could disturb asteroid belts, alter comet paths, or even collide with planets. While the chances are extremely small, the idea of a wandering planet passing near our solar system is not impossible. The galaxy is not empty. It is filled with moving worlds. As astronomers continue to search the sky, they're finding more evidence that rogue planets are everywhere. Each discovery adds another piece to a growing realization: planets do not need stars to exist. And the universe is far more dynamic and chaotic than we once believed. And if Part 1 shows us how these planets are born and lost, Part 2 reveals something even more unsettling, because some of these rogue worlds may not be dead at all at first. The idea sounds impossible. Without a star, there is no photosynthesis, no surface warmth, no obvious energy source. Yet on Earth, we already know of life that thrives without sunlight. Deep beneath our oceans, around hydrothermal vents, entire ecosystems survive on chemical energy alone. Bacteria feed on minerals and heat from Earth's interior, forming the base of complex food webs. These life forms don't care about the sun at all. Now imagine a rogue planet. It's massive enough to retain internal heat, with a thick icy crust ceiling and a deep subsurface ocean. Beneath that ice, geothermal energy could power chemical reactions, just like the vents on Earth's ocean floor. In theory, such a planet could remain habitable for billions of years, drifting silently through the galaxy, while life continues beneath the ice. Some scientists believe this scenario may not be rare. In fact, rogue planets may outnumber habitable planets orbiting stars. If even a small fraction of them host subsurface oceans, the number of potential life-bearing worlds in the galaxy could increase dramatically. Life may not be clinging to warm, sunlit planets alone. It may be hiding in the dark, spread across countless starless worlds. There is also another possibility. Some rogue planets may not have always been alone. Imagine a planet that once orbited a star, complete with oceans, atmosphere, and perhaps even life. When it was ejected from its solar system, it didn't instantly freeze. For millions of years, it would slowly cool. During that time, any existing life might adapt, retreating underground or beneath ice. Entire biospheres could have survived the transition. Becoming trapped on a planet forever, cut off from its sun, these would be true cosmic refugees worlds, carrying the remnants of once thriving systems. The loneliness of rogue planets is difficult to comprehend. Most will never encounter another star closely again. They drift through interstellar space for billions of years, passing nebulae, star clusters, and galaxies without ever being captured. The Milky Way itself rotates, and these planets move with it, like silent ghosts between the stars. Yet despite their isolation, rogue planets are shaping how we understand the universe. They tell us that planetary systems are not stable, orderly machines. They are dynamic, chaotic environments where worlds are constantly forming, migrating, colliding, and being destroyed. They remind us that our own solar system could have turned out very differently, and they raise a deeply unsettling thought. If planets can be lost so easily, Could Earth ever become one? In theory, yes. A close stellar encounter or a passing massive object could disrupt our solar system. The odds are extremely low, but not zero. Over cosmic timescales, even rare events become possible. Earth's stable orbit is not guaranteed forever. It is simply stable for now. That realization gives rogue planets a strange emotional weight. They are not just distant objects. They are possible futures we narrowly avoided. As technology improves, future telescopes may allow us to study rogue planets in more detail. Infrared instruments could detect the faint heat they still emit. Space missions might one day observe their atmospheres, moons, or even signs of geological activity. Some scientists have even proposed that rogue planets passing near Earth could be explored by probes, offering a rare chance to study a starless world up close. And if life were ever detected on one,